Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about orthographic projections of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with an isometric projection of an engineering object in which the front view face, the top view face and the left hand side view face of the solid, they have been appropriately combined into a 3D isometric projection. Now using the available information through this 3D isometric projection, we are going to evaluate the orthographic projections of this engineering object over here. Now in order to obtain the orthographic projections of this object, we are required to determine the dimensions of the front view face, the top view face and the left hand side view face of this engineering object. Now as we are going to look at the solid from the front view orientation, so we observe that the width of the solid happens to be equal to 90 millimeter. So we can check over here, this portion of the solid, it is measuring 60 millimeter, while this circular portion of the horizontal width, it is having dimensions equal to 30 millimeter, which is the radius of this semicircular arc over here. So the width of the solid will be equal to 60 millimeter plus 30 millimeter, that is equal to 90 millimeter, and the height of the solid happens to be equal to 70 millimeter. So the dimensions of the front view face of the solid will be measuring 90 millimeter width of the solid, 70 millimeter height of the solid. Now when we are going to look at the solid from the top view orientation, so we observe that once again the width of the solid will be equal to 90 millimeter, while the depth of the solid will be equal to 60 millimeter. So here we have been provided with the information that the radius of the semicircular arc happens to be equal to 30 millimeter. So the total width of this cross section of the solid will be equal to 60 millimeter over here. So we are going to obtain the dimensions of the top view face of the solid as 90 millimeter width and 60 millimeter depth of the solid. Similarly, when we are going to look at the solid from the left hand side view orientation, so we are going to observe that the depth of the solid will be equal to 60 millimeter, while the height of the solid will be equal to 70 millimeter. So the dimensions of the side view face of the solid will be equal to 60 millimeter depth and 70 millimeter height of the solid. So with this information regarding the dimensions of the three faces of the solid, now we are going to proceed to evaluate the front view orthographic projections, the top view orthographic projections and the left hand side view orthographic projections of the solid. Now in order to obtain the orthographic projections of the solid, we are going to draw the XY reference line, the X1, Y1 reference line and a transfer line which is inclined at an angle of 45 degree with respect to the XY reference line, and this transfer line is originating from the intersection point of the XY reference line and the X1, Y1 reference line, and we are going to use this transfer line in order to transfer the distances alongside the depth of the solid from the top view projections into the left hand side view projections over here. Now in order to obtain the orthographic projections into the first angle projection method, the front view projections of the solid will be obtained above the XY reference line. The top view projections of the solid will be obtained below the XY reference line, and the left hand side view projections of the solid will be obtained on right hand side of the front view projections above the XY reference line. Now, in order to obtain the front view orthographic projections, we know that the dimensions of the front view face of the solid, they are measuring 90 millimeter width and 70 millimeter height over here. So in order to obtain the width of the solid equal to 90 millimeter, we have drawn two vertical projector lines which are separated by a distance of 90 millimeter, which happens to be equal to width of the solid over here. And these two vertical projector lines, we have appropriately extended them into the top view projections also, because into the top view projections also we are going to require the width of the solid equal to 90 millimeter over here. And we also know that the height of the solid, it happens to be equal to 70 millimeter. So now we are going to draw a horizontal projector line at a distance of 70 millimeter from the XY reference line, so that we are able to obtain the front view face of the solid measuring 90 millimeter width and 70 millimeter height of the solid over here. And this horizontal projector line, we have appropriately extended it into the left hand side view projections as well, because we already know that into the side view projections we are going to require the height of the solid equal to 70 millimeter. So in order to obtain the top view projection face, we have to draw two horizontal projector lines into the top view orthographic area over here, such that these two horizontal lines, they are separated by a distance of 60 millimeter, which happens to be depth of the solid over here. So here we have been provided with depth of the solid is equal to 60 millimeter. So here these two horizontal projector lines we have obtained into the top view orthographic projections, and these two horizontal projector lines we are going to transfer them using this transfer line into the left hand side view projection area over here. So now we have been able to obtain the dimensions of the left hand side view face over here as 60 millimeter depth of the solid and 70 millimeter height of the solid over here. Now let us proceed with obtaining the orthographic front view projections of the solid. So in order to obtain the orthographic front view projections of the solid, now we can divide the solid into two portions over here. So here we have got a horizontal wave which is lying at the base of the solid, and here we have got a vertical wave which is lying onto the right hand side portion of the solid. And into this vertical wave we have been provided with an angular slot which is facing the right hand side face of the solid over here. Now we have been provided with this information that the width of this angular slot happens to be equal to 15 millimeter, while the total width of this vertical web happens to be equal to 30 millimeter. Let us first of all obtain all the dimensions alongside the width of the solid into the front view projections over here. So as we have discussed, from the right hand side face, so this width of the angular slot happens to be equal to 15 millimeter. So we have marked a distance of 15 millimeter from the right hand side face of the solid. It is this face of the solid, and we have obtained a vertical projector line at a distance of 15 millimeter from the right hand side face of the solid. And this vertical projector line we have appropriately extended into the top view projections as well. Now we also know that the width of this vertical wave happens to be equal to 30 millimeter. So corresponding to this width of the vertical wave as 30 millimeters. So now from the right hand side face we have marked a distance of 30 millimeter and we have obtained a vertical projector line corresponding to this face of the vertical wave. So it is this face which will be projected as an edge view into the front view projections over here. So here this vertical projector line we have been able to extend into the top view projections over here. Now we have been provided with the information that this center, which is corresponding to the center of the circular portion of the horizontal wave and the center of a circular vertical slot which has been provided into the horizontal wave. So this center point has been located at a distance of 60 millimeter from the right hand side face or 30 millimeter from the left hand side face of the solid. So now we have marked a distance of 30 millimeter from the left hand side face. We have marked a vertical projector center line in such a way that we have extended this center projector line into the top view projections as well. And now we know that from the center location there is a vertical circular hole which has been drilled into this horizontal wave which is having diameter is equal to 30 millimeter. So from this center point we are going to take an offset of 15 millimeter on the either side of the center line so that we are able to obtain the diameter of this vertical circular hole into the horizontal wave as 30 millimeter. So now we have drawn two vertical projector lines which are separated by a distance of 30 millimeter in such a way that the left side black projector line, it is spaced at a distance of 15 millimeter towards the left hand side of the center line, and this right side black vertical projector line, it is located at a distance of 15 millimeter towards the right hand side of this vertical central line over here. So here we have been able to obtain the coordinates corresponding to the location of this diameter of the hole into the front view projections over here. So this way we have been able to obtain all the dimensions corresponding to the width into the front view projections over here. So now let us obtain the dimensions alongside the height of the solid over here. So we know that corresponding to this element number 1 which is lying towards the left hand side portion of the solid, so it is a horizontal web that we are having over here. So the height of this horizontal web happens to be equal to 15 millimeter. So corresponding to this horizontal web height, we have marked a distance of 15 millimeter from the XY reference line, and we have obtained a horizontal projector line into the front view orthographic projections, and we have extended this horizontal projector line appropriately into the left hand side view projections also. And now we also know that towards the top surface of this vertical wave, here we have been provided with an inclined surface over here. So into this vertical wave, we know that towards the left hand side we have to mark a distance of 40 millimeter above the top surface of this horizontal wave. So the distance or the location of this point corresponding to the slant surface of the vertical wave, here we have got 55 millimeter distance from the base of the solid. So now we have marked a distance of 55 millimeter above the XY reference line, that is above the base of the solid, and we have been able to obtain a horizontal projector line into the front view orthographic projection view, and we have extended this horizontal projector line into the left hand side view projections as well. So now, having obtained all the dimensions corresponding to the constructional details of the solid into the front view projections, now we can darken the portion of the solid which is visible to the observer while the observer is going to look at the solid from the front view orientation. So now we can check this portion of the horizontal wave will be visible to the observer in the form of a rectangular surface over here. So this is the rectangular surface which is visible to the observer from the front view orientation. Similarly, corresponding to this front face of the vertical wave, the observer will be able to view the true shape of this vertical wave into the front view projections over here, because this surface happens to be parallel to the vertical plane. So this surface will be projected as a true shape into the front view projection. Similarly, corresponding to this horizontal wave, so this portion only, this portion starting from this point up to the center point, so this portion will be observed once again as a true shape to the observer into the front view orientation, that is up to the center point starting from this position. So this portion is visible to the observer as a true shape, while this portion of the rectangular projection, this is the apparent shape projection corresponding to this horizontal wave. Why? Because this circular portion, it is no longer parallel to the vertical plane. So since the circular portion which is lying at a distance of 30 millimeter from the left hand side face of the solid, so this distance happens to be 30 millimeter from the left hand side face of the solid. So this projection, it is the apparent shape projection, while this projection which is visible to the observer in the front view projection, this is the true shape projection into the front view projections over here. So next, we also know that corresponding to this angular slot, so at a distance of 15 millimeter, here we are going to get two vertical edges over here. One vertical edge will be lying over here, another vertical edge will be lying over here. So both of these vertical edges, they are going to overlap with each other into the front view projections, and these two vertical edges, they will not be visible to the observer from the front view orientation over here. So that is why corresponding to this angular slot, we are going to observe a hidden line projections into the front view projections over here. Next, we have got this particular point. So we can check, we had started from this point which is lying 30 millimeter from the right hand side face of the solid, and this point has been located at a height of 55 millimeter above the base of the solid. So we can check it out over here, 55 millimeter above the base and 30 millimeter from the right hand side face of the solid. So this point has been located, but we have not been provided with the location of this point. So in order to locate this point, we know that at a distance of 15 millimeter from the right hand side face, so this point has been located over here, because we are going to require this point into the left hand side view projections as well. So what we have done over here, we have drawn another horizontal projector line originating from this point, and we have extended this horizontal projector line into the left hand side view projection view over here. So this way we have been able to obtain the location of this particular angular projection, the height of this angular projection into the left hand side view projection area as well. And finally, into the front view projections, we know that we have drilled a vertical circular hole into this horizontal wave at a distance of 60 millimeter from the right hand side face or 30 millimeter from the left hand side face. But this circular hole is not visible to the observer from the front view orientation. So we have obtained the hidden line projections corresponding to this hole, which is having diameter is equal to 30 millimeter into this horizontal wave, which is our element number 1. So this completes the construction of front view orthographic projections of this solid. So now we are going to proceed with the construction of the top view orthographic projections of this solid. So we know that into the top view projections, the depth of the solid happens to be 60 millimeter, while the width of the solid happens to be 90 millimeter. And we also know that this circular hole, it is located centrally alongside the depth of the solid over here. So the total depth of the solid happens to be 60 millimeter. So now the center of this hole will be lying at a distance of 30 millimeter from the rear face of the solid. So we have marked a distance of 30 millimeter from the rear face of the solid, and we have marked a horizontal center projector line into the top view projections, and we have transferred the center projector line into the left hand side view projections also using this transfer line. Next, we know that corresponding to this angular slot which happens to exist into this vertical wave, so the location of this point from the front face towards the right hand side face into the vertical wave, we will be able to locate at a distance of 20 millimeter from the front face of the solid. So from the front face of the solid, we have marked a distance of 20 millimeter, and we have obtained a horizontal projector line into the top view projections, and we have transferred this distance of 20 millimeter from the top view projections into the left hand side view projections using this transfer line. So now this point will provide us with the location of the angular slot which is starting from the right hand side face of the solid over here. Similarly, corresponding to this point, we know the location. This point is located on the right hand side face of the solid at a distance of 20 millimeter from the rear face of the solid. So from the rear face of the solid, which is this face, we have marked a distance of 20 millimeter, and we have obtained another horizontal projector line into the top view projections, and this distance of 20 millimeter depth from the rear face we have transferred appropriately into the left hand side view projection view using this transfer line over here. Another thing we know that at the interior portion, which is the end point of the angular slot, it is lying at a distance of 15 millimeter from the right hand side face of the solid. So we know that the depth of the slot, it is equal to 40 millimeter. So now at a distance of 15 millimeter, this distance happens to be 15 millimeter. So we need to obtain the dimension of the slot equal to 40 millimeter, such that this 40 millimeter will be again distributed symmetrically across this center line. So now from this center line we have taken an offset of 20 millimeter towards the rear face of the solid, 20 millimeter towards the front face of the solid, and two horizontal projector lines which are going to depict the depth of the interior portion of this angular slot over here at a distance of 15 millimeter from the right hand side face of the solid. So at a distance of 15 millimeter from the right hand side face, so this 40 millimeter depth of this angular slot we have been able to obtain over here, and these two horizontal projector lines, once again we have transferred them into the left hand side view projection area using this transfer line over here. This way we have been able to obtain the constructional details regarding the various elements which will be visible to the observer from the top view orientation. So let us proceed with evaluation of the surfaces which will be visible to the observer from the top view orientation. Now we can see here we have got an inclined top surface of this vertical web which will be visible to the observer from the top view orientation. And now since we know that this is an inclined surface which is available at the top surface of this vertical web, and this inclined surface, it is not parallel to the horizontal plane, so we are not going to obtain the true shape of this inclined top surface of the vertical web into the top view projections over here. So we have been able to obtain the apparent shape projections corresponding to this vertical web top surface over here. Now since this top surface of the horizontal web, which is our element number 1, it happens to be parallel to the horizontal plane, so we will be able to obtain the true shape projections corresponding to this horizontal web into the top view projections over here. So now from here, the center point of this semicircular arc, it has been obtained over here. So this is our center point. So we know that the radius of this circular portion, it happens to be equal to 30 millimeter. So with this center point, we have been able to obtain the circular portion, and here we have got this flat portion of this horizontal web over here. So this is the true shape of this horizontal web which has been obtained into the top view projection. And besides this, we also know that through the center point we should be able to obtain a circular hole having diameter is equal to 30 millimeter. So here the center point has already been obtained. So through this center point we have obtained a circular hole having diameter is equal to 30 millimeter over here. So now this is the circular hole having diameter which we have marked appropriately into the top view projections over here. So now this surface which we have been able to obtain into the top view projection, so this is the true shape projection which we have been able to obtain over here. Now we know that the diameter of this circular hole, it happens to be 30 millimeter. So we can check this we had obtained as a dotted projection into the front view projection, because these two vertical edges of the circular hole, they were not visible to the observer. So the true shape of the circular hole we have been able to obtain into the top view projections over here. So now we have to transfer this distance of 30 millimeter diameter from the top view projections into the left hand side view projections over here. So these two black horizontal projector lines we have marked corresponding to the diameter of this hole alongside the depth over here, and this distance we have appropriately transferred into the left hand side view using this transfer line. And we can check, because this hole is available alongside the left hand side portion of this horizontal web which is having height is equal to 15 millimeter. So that is why we have not extended these two black projector lines up to the top of the solid, because the hole will be visible to the observer from the left hand side portion into this horizontal web over here. So with this we have been able to obtain the top view orthographic projections of this engineering object. So let us proceed to evaluate the left hand side view projections of the solid. Now as the observer is going to look at the solid from the left hand side, so the first thing which will be visible to the observer is this horizontal web. So this circular portion of the horizontal web will be visible to the observer as an apparent shape, as a rectangle over here. So this rectangular projection, it does not depict the true shape of this circular web. And another thing we also know that corresponding to these two endpoints of the diameter. So two vertical edges, they are available, which are not visible to the observer from the left hand side view over here. So now the hidden line projections we are going to obtain into the horizontal wave in the left hand side view projections over here. Now as we proceed to evaluate the projections of this vertical wave, now we can check. So this portion, this portion, this portion and this portion. So this will be visible to the observer corresponding to element number 2, which happens to be a vertical wave carrying an angular slot towards the right hand side portion of the solid. So we can check. So this portion will be visible to the observer. Now as we look at this vertical wave, one thing we must clarify over here, this portion, that is the left hand side portion of this vertical wave. So since this left hand side portion of the vertical wave, it happens to be parallel to the profile plane, so we are going to obtain the true shape projections corresponding to this face of the vertical wave over here, whereas corresponding to this inclined surface of the vertical wave, we will not be able to obtain true shape projections of this inclined top surface. Why? Because this inclined top surface, it is not parallel to the profile plane. So we will be able to obtain a shortened view or an apparent shape view corresponding to this inclined surface of the vertical web over here. And another thing we should observe over here, corresponding to this point and corresponding to this point, there will be two vertical edges which will be starting from this point and this point up to the base of the solid. So these vertical edges, they will not be visible to the observer from the left hand side view over here. So we are going to obtain the hidden line or the dotted line projections starting from these 2 points corresponding to this vertical web over here. Similarly, we have got two vertical edges, one originating from this point and another one originating from this top point over here. So corresponding to this point and corresponding to this point. So again, these two vertical edges, they are not visible to the observer from the left hand side view orientation over here. So once again, we are going to obtain the hidden line projections corresponding to the vertical edges of the angular slot over here. So these 4 vertical edges corresponding to this angular slot, since they are not visible to the observer from the left hand side view orientation, so they have been obtained as hidden line projections into the left hand side view to orthographic projections over here. So with this, we have been able to obtain the front view orthographic projections, the top view orthographic projections and the left hand side view orthographic projections of an engineering construction, corresponding to which a 3D isometric projection was available with us. So this is all for today. So I hope that through this discussion you would have understood about the procedure, how do we proceed to evaluate the orthographic front view, top view and left hand side view projections of a solid when the isometric 3D projections of the solid, they are available with us. So we are going to continue with further discussion regarding few more illustrative cases of orthographic projections of the solids in the coming lectures. So thank you very much. Thanks a lot.